Hey ladies and gentlemen, it's Mr. Anderson one last time with you in section 3.2. We're going to talk about the fourth part of this, and our goal today is going to be to generalize this process to make it applicable so that it works for us. It's a tool that we can use. One more time, I'm going to build on this idea using the manipulatives, using algebra tiles, but then we're going to take and we are going to kind of advance past that. We're going to go with the more generic or general sense. We start with the distributive property. This is where we left off in our last lesson. And we've got a problem here in part A that has us doing some distributing. And this right here, I think you guys will see, is a pretty nice and manageable thing to distribute. But let's talk about how we would do this using our algebra tiles. We've got 6 times the quantity of negative 3x and 2, and I set this one up ahead of time using some algebra tiles. I've got negative 3x and 2, and I'm building over here 6, and you guys can see what's going to happen. What, I got 5 there, 5 here, 6. You guys can see what's going to happen. This one will work out. All right, but let me show you just conceptually what's going to be happening here. I've got 1, I've got negative x. I can take and I can multiply this. This would take me a while, which is why I'm just going to kind of lead into this. And I could do that again. And I could keep going with this. I'd be spending a lot of time here, but and what I'm showing you is that maybe algebra tiles aren't the most reasonable practice here, right? Which is why we're generalizing, but they would work if you needed them, right? We can multiply a positive times a negative, and it's going to work out. You can imagine all these algebra tiles stacked up and all these single unit tiles stacked up. So maybe that generalization piece is more helpful here. Let's do the multiplication. And we've got 6 times negative 3x. That does work out to be negative 18x. And then I do need to follow up with the 6 times 2, which is, of course, 12. Notice, just like we would see here in the algebra tiles, I'd have some negatives. I'd, in fact, have negative 18. And then I'd have 1 times 1, right? These tiles, as I backed everything away, they would not match, right? They're not the same shape. They're not the same size. They could not be combined, and thus I'm not going to put the negative 18x with the 12. I'm going to go slightly out of order here. You can kind of see my arrowing. I'm now going to move on to 5t and then multiplied by the quantity of 10 minus 3t. Ladies and gentlemen, this one will work out as well. Maybe it's a little tougher to use algebra tiles because we'd have to imagine the x's, the t's being x's, but it would work, right? 5t times 10. The 5 has a t on it, the 10 does not, so I just multiply those coefficients. 5 times 10 is, of course, 50. The t comes along, right? It's me taking 5t 10 times, I get 50t. Now I'm multiplying the 5t times the negative 3t. Well, I know a positive times a negative is a negative. I'll multiply those coefficients. 5 times 3 is 15. But here, each one of them has a t. So I'm going to multiply t times t, and when I do so, it's just like over here, multiplying x and x. And I can show you that here. Whoops. Sorry. I want to open up a new algebra tiles window. P.S. in case you'd forgotten, your algebra tiles are always in your E-tool. Whenever I multiply, and I can change my background to the corner piece, whenever I multiply an x and an x, or a t and a t in this case, remember, I don't end up with 2x. Remember, x and x, they multiply to make that rectangle of x squared, right? Likewise, t times t is going to make for me a t squared, and that's how I would write that. 50t minus 15t squared. Let's keep on. Let's go this way. I've got x squared times 4x plus minus 2y. The distributive property, distributing a monomial over a binomial, is going to work here. Let's do this first part. X to the second power times 4x. That's like saying 1x squared times 4x. That's going to be 1 times 4, which is 4. X squared times x is x to the third, right? Think of what we did last week or in our last set of units where we said, hey, that's like 4x to the first power, and I can add those exponents. 2 and 1 make 3. Okay, now I'm going to multiply the 1x squared times negative 2y. 1 times negative 2 is, of course, negative 2. This is where maybe it gets a little confusing for you. I've got x squared times y. That's going to be x squared y. Writing those things as separate factors because they're not the same base. I can't combine them and increase the exponent. I've got to leave them separate. Okay, one last one of these for us to try here. This is going to be negative 4w times the quantity of a trinomial here, 8 minus 6k squared plus y. Okay, let's go ahead and do this. We'll do this piecewise. Negative 4 times 8, that's negative 32w. Okay, let's keep on. All right, negative 4 times negative 6k squared. Negative times negative is a positive, I know that. And then 4 times 6 is 24. Now here's where I don't have the same basis, so I can't put the k and w together and increase the exponent. I will write the k first. That's often how it's done. We write those in alphabetical order, but if you put wk squared, that's fine. Just understand we don't have a w squared. All right, the k is the only thing that gets the square. All right, last part of this is going to be the negative 4w times y. All right, negative, oh, that's like a 1y. I should remember that, right? Negative 4 times 1. Okay, that's negative 4. That negative doesn't look great. Let me clean that up a little bit. Negative 4. And then I've got w times y. They're not the same base. I can't put them together. So I will just write those things in alphabetical order. W, y. Okay, there we go. We've got that distributive property down. We're now advancing. We're generalizing. We're doing things without the algebra tiles, but those algebra tiles are there as a support if we need them. All right, we've got another piece here before we generalize this idea of a rectangle where we are given a rectangle and we are going to write it as a product and as a sum. So I'm going to get that set up for us here. I've got the ability to write the sum over here on the left-hand side, and if you want to go ahead and write it on the right-hand side, you definitely can, but we've just kind of been doing that on the left. And over here, I'm going to write it as a product. When you have the rectangle like we have here, it might be easiest to write the sum first. So I've got some x squareds, and the x squareds, I'm just going to go ahead and start counting. I've got an x squared, 1, 2, 3, 4, 5, 6, 7, 8 of them. I've got 8x squared, so I'll back up over here, and I'll just make that note, 8x squared. Okay, that's pretty manageable for me. The next thing I'm going to count is my next biggest tile. I'm going to count those x's, and they're in 2 spots here. So I'll just kind of, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I've got 22 of those x's. So 8x squared, I am going to write plus 22x because I do know it's shaded, and the shaded ones are the positive ones. The white ones, the unshaded ones, were the negatives. Okay, last but certainly not least, I've got those little itty bitty unit tiles. How many of them? Oh man, let's see. Okay, let's do some counting here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got 15 of those. There, that is going to complete my sum. I've got 8x squared plus 22x plus 15. Ta-da! Okay, last part is now let's go ahead and identify that product. We do so, remember, using the dimensions. I've got, let's pick a new color here. I've got x and x and x and x. That's going to be 4x. And then I've got 1, 2, 3, 4, 5. I got 4x and 5. There's one dimension. All right? One dimension, 4x and 5. Okay, pick one more color here. I'm going to go along the other dimension of this rectangle. I've got x, and then I've got 1, 2, 3. That's going to be 2x and 3. There's the other dimension. And ladies and gents, this is going to empower some of our abilities to do some things in the future, you know, like solve. Okay, that's the point. That's where we're headed. We will get there. Okay, so check it out. I tried to color code some things for you. You're welcome to pause this, throw this down in your notes. It might be helpful to have some colors, but now let's take this and let's move on to this general idea. All right, this general idea is going to be using some generic rectangles, and I'm going to on purpose leave the previous problem on the screen there, but I'm going to show you, ladies and gents, that we have the exact same thing here and here, the exact same thing here and here. So we're really kind of dealing with the exact same rectangle, but they look slightly different. Okay, same thing right here. We've got 8x and 22x, 8x squared, I'm sorry, and 22x and 15. I've got an 8x squared here. I've definitely got a 15 here. And do you see the 22x? Okay, so look at that. That generic rectangle is really going to allow us to do some pretty nice, solving, factoring, stuff like that coming up, right? And you guys can probably see maybe, or start to see maybe, how that distributive property is going to fit in here. All right, let me grab a brighter color. Do you see the 2x and the 4x? Can you imagine how they come together to make that 8x squared? If not, maybe it's easier to go with the number parts, right? What if you consider the 3 and the 5? Do you see how they get that 15? Right? Do you see where that comes from, right? It's a product, right? That's what we've been working on for quite a while, okay? And then, of course, we do have to multiply, for example, the 3 and the 4x, and they do give us the 12, and then the 2x and the 5, they give us the 10, and then finally, we got to take those things and we got to sum them. We got to put them together, and that's where the 22 comes from. All right, a couple generic rectangles. I'm not going to draw these on my paper. I'm just going to go through a couple of these, and then I'm going to throw a challenge your way. We're going to talk about some review preview, and we're going to be done for today. Some generic rectangles just have us doing some of this multiplication and then writing it as a sum. Check it out. I've got a dimension here. I've got a dimension here. I want the area of just that part. 3y. 3 times y is just 3y. Now, I've got a dimension here. Whoops. A dimension here and a dimension here. I want to write the area of just this part. 3 times 5 is 15. Now, don't just stop there filling in the rectangle. Write it as a product and a sum. What we've said when we've done this is, let me use a new color here. I've got 3y plus 15. What is that the same thing as? That's the same thing as the product of those dimensions. That's going to be 3 times y plus 5. There you go. You're using that generic rectangle for the idea conceptually that the product is equal to the sum. We can do the exact same thing with a more difficult example. I've got it down here, folks. Let me try maybe a bit different of a method to show you this. I've got 5 and I've got -3. Do you see where they come together? 5 times -3 is -15. Okay, let me try something slightly different. Modify that color. I've got I've got -3 times x. -3 times x gives me a -3x. Okay, let's change the color one more time. I've got 2x times 5. 2x times 5 gives me 10x. And then finally, and don't forget this is usually the number one mistake students make. They forget the exponent. 2x times x. 2x times x, that gives me a 2x squared. Now don't just stop there. Fill in your product and your sum. My sum, 2x squared. Combine your like terms, 10x and, let me get just one more different color highlighter. I'm sorry about this. 10x and -3x works out to be 7x. And then finally, minus 15. Set that equal to the product. I've got 2x minus 3. And finally, I've got x plus 5 on that other dimension. Okay, a little bit of review preview coming your way. That review preview is just 3 problems. 70 to 72, right? I'm going to zoom back out in case you want to see those generic rectangles again. But there is a problem that we didn't get to. Now, this is where you get a little freedom, a little bit of choice. We've got number 69 in the book, and I didn't have time for the sake of this video to do this, but I'm going to show you that we have a generic rectangle challenge here. And if you're going to push yourself, you're going to try this, you're going to go ahead and, oh, I don't know, try to figure out what algebraically fills in this blank. Okay? So you might ask yourself this question, what goes there? And if I know what goes there, could I figure out what goes here, here, and here? Ladies and gents, thanks for watching. Have a great day.